Okay, let's continue with our questions on trigonometry for paper 2. Uh, this paper is November 2021. Let's try to do this question. It says the diagram shows two triangles AB and BC and CD and AC. I can see all the lengths there. It says calculate DAC. So I'm asking you to calculate this angle. So let's call that X. Screen seems to be a little stuck. Let's see if it moves now. Yeah, it is. Okay. Calculate DAC. So I can say that this is basically the sine rule. So I can see sine x over 3.8 equals to sine 63 over 5.3. Remember that the sine rule applies to all cases where the cosine rule doesn't apply. The cosine rule applies when you have three sides or you have two sides and the angle between them. So those are the two cases for cosine rule. This is the sine rule. Let's quickly try to do this. I'm going to multiply 3.8 onto the other side and then take a sine inverse. Okay, so sine inverse of 3.8 sine 63 divided by 5.3. Okay, so I'm getting 39.7. 39.705, which is 39.7 degrees, because answers in degrees are correct to one decimal place. Okay, then it says calculate ABC. So again, three sides given, so I'm going to use the cosine rule again. Cosine rule this time, cos y. I told you before as well that this side gets subtracted, so I'm going to first write that with a negative sign here. Then I'm going to add the other two, 6.4 square plus 9.7 square. 2 into 6.4 into 9.7. Okay, then y is basically cos inverse of all of this. Okay, cos inverse 6.4 square plus 9.7 squared minus 5.3 squared over 2 into 6.4 into 9.7. .5. That is my answer. Okay, moving on. Let's just verify our answers just to be sure. 30.5 and 39.7. Yes, those were the two answers. Okay, that's the next paper then. This is November 2022. In triangle ABC, AC equals to 6.4, BC equals to 9.5, and BAC is equals to 79. Calculate ABC. I'm asking you to calculate this angle. Now remember that paper 2, you can obviously see that most of these questions are every question, every paper nearly has a question on sine rule or cosine rule. So remember that those are four easy marks that you can obviously get on the exam. This is also again 3 marks. So remember to do these questions carefully and properly so that you get these easy marks. Calculate ABC. So again, I have two angles. That means I'm supposed to use the sine rule. So sine x divided by 6.4 sine 79 divided by 9.5. So sine x equals to 6.4 sine 79 over 9.5. Sine inverse of 6.4 sine 79 over 9.5. So sine inverse 6.4 sine 79 divided by 9.5. I get 41.399, which is 41.4 degrees. Let's just calculate the area of triangle ABC. Now, as in the last video, I told you that area in this part of the chapter would be half AB sine C, where A and B are the two sides, and this the angle is the angle between them. Now, this question is therefore a little tricky. If you end up using these two sides and you end up using this angle, you'll get a wrong answer. So if you're using these two sides, you need this angle. Let's call that theta. How would you calculate theta? You would say the theta is basically 180 minus 79 minus the angle that you just calculated, which is 41.4. So I'm going to write all of that, which is why this is a 3-mark question. Otherwise, it's sometimes a 2-mark question as well when it's a straightforward formula. So I get 59.6. So I'm going to say that half 9.5 into 6.4 into sine of 59.6. That's something that you have to remember. That's 52.4. It's 52.44, 3 significant figures is 52.4. So I can give you the final answer then. Okay, the second part of this question is actually very interesting. It takes you to three-dimensional trigonometry. So three-dimensional trigonometry will have some ideas that you need to be careful about. Those ideas are actually come in very handy when you are doing mensuration as well. So when you have pyramids, for example, this idea becomes really important as to when it is a right angle or when it is not a right angle and so on. So that's something that you need to be careful about. Okay, this same triangle ABC forms the base, horizontal base of a pyramid. So let's just write down our angles that we just calculated so that we have all of them. B was 41.4 and 59.6. So 41.4 and 59. Not that I don't think we're going to need this. I'm just writing them down just in case. The sides are given to you. It says calculate angle BDC. So BDC. This is the angle on the slant part of the sort of pyramid that you have. So remember that I'm talking about a slant edge. So I'm just looking at these sides, 9.8, 8.2 and 9.5. Now the triangle can be slant, and you can again sort of apply the cosine rule because you have three sides. So you apply the cosine rule. I'm looking for an angle that's angle D. Let's call that angle D. So cos D. What side am I going to subtract? I'm going to subtract 9.5 squared because it's on the opposite side of the angle that I'm trying to find. The other two sides get added, 9.8 squared plus 9.2 squared divided by 2 times 9.8 times 9.2. Okay, cos inverse of this. I'm not writing the entire thing now. So I can say that this is 59.9. Then it says calculate the angle of elevation of D from C. Now remember that it's very difficult to see the angle and the right angle and all of that in the three-dimensional diagram. So what I always do is whenever I want to calculate the angle of elevation, I do this. So I want to calculate the angle of elevation of D from C. So D is here and I want this angle of elevation. Now I should know where it's dropping 90 degrees. Let's look at our diagram. So D drops a 90-degree line onto A. So this point is going to be A. Do you know the length of AC? Yes, you know the length of AC, and that is 6.4. So I know this much. If I want to calculate an angle, I must have the third side as well. So what other side do I have? I already have CD, if you notice. So CD is 8.2. So I'm going to write 8.2. So this is just then cos inverse, cos theta equals to 6.4 over 8.2. Theta equals to cos inverse of 6.4 over 8.2. Okay, so 38.7 degrees. Let's quickly verify we got those answers correct. This was question number 9, 41.4, 52.9, 41.4, 26.2. I didn't get 26.2. Did I make a mistake? Let me calculate again. Oh, I haven't divided by 2. Sorry. My mistake in the calculation. 26.2. And then part B1 is 63 or 62.9. Why is my answer again different? I've been doing calculation mistakes, I think. 8.2. 8.2. Very silly mistakes. Apologies for that. Yep, 62.97 or 63.0. And that one should be correct. 38.7 is correct. Okay, so small mistakes there. Let's try not to make them again. The diagram shows the positions of three villages P, Q, and R. R is due west of P and Q on a bearing of 140 degrees from P. PR equals to 3.8 and QR equals to 7.5. Calculate the angle P or Q. Okay, so I'm looking for this angle. Let's call that X. So the problem with this question right now is I don't have two angles right now, so the sine rule looks something that I can't apply. I also don't have three sides to find out the angle, so I can't really apply the cosine rule. So I have to do something first. It is a 4-mark question. I see that I can calculate this angle. So the entire thing is 270, so I can just subtract 140 from 270, and that gives me 130. Okay, so what I've done is 270 minus 140, so that gives me 130. Why 270? Because this is 180 plus 90, which is 270. Okay, that's three quadrants. 130. So now I have two angles. Can I simply say that I want to find this angle P or Q? But I see that when I also apply the sine rule, this is fine. Sine 130 over 7.5. But if I keep sine x, I will have to keep the side PQ. But I don't have PQ. What I have is PR. So if I keep PR here, I have to basically call this angle theta and find out sine theta first. So what is PR then? PR is 3.8. So let's just write that here. So instead of calculating that angle, I'm calculating the other angle. But I know that if I have two angles of a triangle, I can simply subtract it from 180 and get my final answer. So 3.8 into sine 130 divided by 7.5 equals to sine theta. So let's do sine inverse of divided by 7.5. And I get 22.8. Since I made some silly mistakes in the last one, let me just quickly verify this one. 4A. Okay, that's not my final answer. Why? Because I didn't want that angle. What angle did I want? I wanted the other angle, so let's calculate that. So 180 minus, what's 22.8? 22.8 minus 130. Let's see if we now have the correct answer. 27.2. Yep, that's the correct answer now. Okay, moving on. Work out the bearing of R from Q. R from Q. Wherever it says from, you're supposed to draw a north or the axis on that. So what angle am I trying to find? I'm trying to find this entire angle up till I find the value of R. Up till I reach the line for R. So work out the bearing of R from Q. So I need to work out this angle that I've drawn in blue. Now it's always wise to sort of draw the axis. I've also drawn the horizontal axis, which I see creates something like this. So then it becomes very simple. This angle is 27.2 as we just found out. So this angle should also be 27.2, the smaller one here. So I can just say that this is basically 270 plus 27.2. And that gives me 297.2. Let's check. Yes, that is the correct answer. Then the distance between the villages P and T is this. Kwesi leaves village P, traveling at an average of this. He stops in village T for 15 minutes. He then drives back. Calculate Kwesi's average speed in kilometers per hour for the journey from the village T to village P. Okay, so this question is then about speed time. Let's quickly do this. From P to village T is, there isn't a village T drawn. Okay. Okay, so the distance is 16.5. He travels at an average speed of 45 for the going part of his journey. So what is his time then? He leaves at 10:30, but time equals to distance over speed. That's 11 over 30. Okay, minutes is 11 over 30 into 60. That gives me 22. Okay, so it took him 22 minutes. So if he started off at 10:30, if I add 22 minutes, that gives me 10:52. So it's 10:52 when he's reached village T. He stops there for 15 minutes. So if I spend more 15 minutes, I can say that this should then become 7, and this becomes 0. Why? Because you have 60 minutes, you add 1 here, and it becomes 11:07. Okay, so it's 11:07 when he decides to head back, and he reaches at 11:35, which means that it took him 35 minus 7. It took him 28 minutes. 28 minutes, or in hours, if you want to, 28 over 60 hours. What was his speed? So speed equals to distance over time. It's the same distance. The time is different in this case. 28 divided by 60, 16.5 divided by 28 over 60. 35.35, which is 35.4. I hope that's the correct answer. Yes, that is indeed the correct answer. So a lot of calculations, which is why it's 4 marks, you see. Okay, quickly moving on to the next question. It says ABCD is a field on horizontal ground. The bearing of B from A is this. To be honest, this question is about bearings, and I'd rather skip this. In fact, this is a 5-mark question, so let's just do that. Let's not skip it. Although bearing is something that's already come up in P1, it's more or less not expected in as much detail in P2, but let's just do it. The bearing of B from A is 0.70. So this is 70. The bearing of D from A is 125. So this entire thing is 125, which tells you that this should be 55. 125 minus 70. 55, yeah. Okay. C is due south. So this is the right angle triangle and due east. AD equals to 290. Calculate the bearing of D from B. So this is already a north drawn here. So what I'm asking you is the bearing of D from B. So I'm asking you to calculate this angle up till the blue point from B. Okay. So what I'm going to basically need is this small angle here. If I can somehow find that small angle, that should solve my question. One thing that I do notice here is that this entire angle has to be 70. Why? Because I see alternate angles here. So if I can just calculate this angle on the inside, I can just subtract that from 70 and get my final answer. And that should work. It's a 4-mark question. That's why you first have to apply the sine rule. So you start applying, you say sine 55. And let's call that angle X. Call that angle X. Over 350 sine X over 290. 290 sine 55 over 350 equals to sine X. Okay, so I've done sine inverse as well. I get 42.7. So that's 42.7. Let me just check my answers again. Looks a little odd, but I just want to be absolutely sure. Yeah, I think that's fine. Okay, that's 42.7. So I subtract that from 70 to get the small blue angle here. So I'm going to say that 70 minus 42.7. That gives me what? 70 minus 42.7. That gives me 27.3. So the bearing is simply 180 plus 27.3. That gives me 207.3 degrees. That's a 4-mark question. Let's see if we got that correct. 207.3. Yes, that's the correct answer. Okay, so a lot of trigonometry there, but bearings as well. So I was a little hesitant, but that's fine. Then it says a vertical mast is positioned at D. So there's a vertical mast. Now I'm talking about 3 dimensions, so I can't draw this on this diagram. It says the angle of elevation of the top of the mast from A is 10 degrees. So if you're watching this mast from A, it has an angle of 10 degrees. Calculate the angle of elevation of the top of the mast from C, but you don't want to watch it from A, you wanted to watch it from C. So it's still at D, the height is going to be the same, and that's the angle that I'm looking for. So if we've done a question like this before, let's see why this is 5 marks, although it's a lot more marks than that was. One of the reasons might be that you don't have, but in fact you have AD, but you don't have CD then. Oh, okay. That sort of makes one additional step. Let's do that. So AD is 290. So that should tell me what the height of the mast is. So I'm going to use tan 10 equals to h over 290. So h is 290 tan 10. H is therefore 51.13. Let's write 51.13. So that's 51.13. Do I know CD? No, I don't know CD, but can I use the right triangle now, given that I have this small angle that I was supposed to calculate, and that angle is 27.3. I have its hypotenuse, and I'm looking for the opposite side. So can I use my question to say that sine 27.3 equals to opposite is CD, and hypotenuse in my case is 350, so divided by 350. Cross multiply 350 sine 27.3 and CD is therefore 160.53. So that's 160.53. So again, tan theta equals to 51.13 divided by 160.53. Tan inverse So I can obviously imagine the angle of elevation getting reduced. One of the simple reasons is that I'm moving further away. Let's see if my theory works and if I've done the calculations correct. Make a lot of silly mistakes. Oh, I have not moved further away. I have moved closer by so 161. I've just drawn it really weirdly. 17.7. 17.7 because I moved closer to D. I was first at a distance of 290, now I am at a distance of 160, which means that I moved closer, which means that I have to sort of look up higher up in order to get my angle of elevation. So 17.7. Let's check if that's the correct answer. It says 17.6 to 17.8, which is why you're right there in the middle, so that's absolutely fine. Okay, moving on to the next question. This is again also about bearing first and okay. So I think it's June 21 that I'm solving, right? No, it's June 22 and the paper is 2. Okay. The diagram shows the positions of 3 towns A, B, and C. On B is on a bearing of 72 from A. So that's 72. And then C is at a bearing of 150. So that's another 78. That makes a total of 150. AB is equals to 300. AC equals to 280. Find the bearing of A from C. Okay, 1 mark question, which means I don't have to do a lot of calculations. It's simply about bearings. So I am looking for this angle then. Bearing of A from C. So I'm looking for this angle. Let's try to figure out where our alternate angles are. Let's stretch this. If this total was 150, then 180 minus 72 minus 78 would give me this as 30. If this is 30, that is also 30. So that sort of solves my question. It's 360 minus 30, and that gives me 330. Relatively simple. Then it says calculate BC. So I'm going to erase all of that I've drawn just to show you. I want this side. I have 2 sides and the angle between them. So I can just simply say that this is the cosine rule. So I'm going to say that the cosine rule with the side form. So BC squared. I have the 2 sides 300 and 280. So 300 squared, 280 squared minus 2 times 300, 280 cos of 78. Okay, root of answer. So BC comes out to be 365.33. So 365 to correct to 3 significant figures. Let's check if those are the right answers before we move on. This question number 9, A and B. Yeah, those are the 2 correct answers. Then says town D is 145 kilometers from B. Town B angle ADB is 120 degrees. Find the 2 possible bearings of D from A. You may add lines to sketch. Okay, so this is a 5 mark question. So this is possibly about both trigonometry and some amount of loci as well. I'm going to try to do my best in order to solve this question. So angle ADB is 120 degrees. So just trying to draw an angle 120 degrees here. This angle is 120 degrees. Find the two possible bearings of D from A. Okay. We'll have to figure out what's two possible bearings. That's one possible bearing that I can think of. That's how ADB could look like. That's 120 degrees. How else could I draw D? Okay, let's just first try to do this one. So if I'm looking for the angle of bearing from D from A, so I need to figure out what this angle might be. So that's the angle that I'm looking at. So I'm going to say that sine x over 145 equals to sine 120 over 300. So let's figure out what x is. Okay, this angle was also what? This angle was 72. Okay, just try. Let's write that down. Okay, that's where I'm thinking that the logic lies. Okay, sine x, sine 120 into 145 divided by 300. So that angle comes out to be sine inverse of answer gives me 24.7 degrees. Okay, so that's 24.7 degrees. Okay, so in that case, what my bearing would be is 72 plus 24.7 degrees. 72 plus 24.7 degrees gives me 96.7. So I'm going to write 0 96.7. So that's 0 96.7. Okay, that's just, barely there. If I were to restructure this diagram a little, so you understand that it's going to be just a line like that. And that's going to be something that the diagram could look like. Okay, my sketch is a little weird, but that is what it would look like. Why? Because D could be somewhere here as well. So I could have it here as well, or 120 degrees. So that angle would then be 24.7. Okay, in that case, the bearing would be 72 minus 24.7. And that's 47.3. So 0 47.3. Yes, that is the correct answer. Okay, so both answers are correct. Let's move on to the next question. This says PQ is a vertical pole, a rope is attached. Again, this goes into 3 dimensions. I'm just seeing how many questions more to go so that I can plan my lecture accordingly. Okay, so PQ is a vertical pole. A rope is attached from the top of the vertical pole P to a point on the ground R. PR equals to 20, RQ equals to 11, and all of that. Show that PQ equals to 16.7. So I think that's a simple Pythagoras theorem. PQ squared equals to PR squared plus RQ squared. PQ is then the root of this. Okay, that should work out. Okay, I've written it wrong. Okay, that's a simple question on Pythagoras theorem then. So PR is the hypotenuse. So RQ is this 11 squared, sorry, not 12 squared, 11 squared plus PQ squared. So PQ is therefore, this is the root of 20 squared minus 11 squared. Then take a root. Gives me 16.7. Okay, a second rope is attached from P to a point S. PQS is this. The angle of elevation of P from S is 30 degrees. So let's draw a right triangle first. to understand what the question is saying, the angle of elevation of P from S. So that's P. It's dropping a vertical down at Q and it's being viewed from S. So that angle is basically 36 degrees. I don't know the length of SQ since I haven't calculated that. RQS. Okay, S is on the ground. Okay, PQS is also 90 degrees. The second group is attached to S. Okay. The question is then asking you to find RQS. It's asking you to find the angle at the bottom. Okay. So what I'm going to say is that do I know the length of PQ? That's what I just found out. It's 16.70. Okay. 16.70. QS is something that I could then figure out. I could just use tan 36 because I have the opposite and I want the adjacent. So QS is then 16.7 divided by tan 36. That gives me 22.9. Now, a common mistake, 22.99. Let's call it 22.99 because it gets rounded off to 23.0, but I don't want to do that right now. It is actually 9.986, so let's just keep it as accurate as possible that we don't make a mistake. Okay, so what I was saying is that it by nature it looks like it's 90 degrees, and a lot of people would go on and have the tendency to write 90 degrees, but you see it's a 5-mark question. So what I then see is there's a triangle at the bottom that has 3 sides, and what I'm looking for is an angle between them. So I know that when I have 3 sides, I can just find the angle using cosine rule. So I'm going to say that cos q, that's the angle that I'm trying to find. So 30 square gets subtracted, 11 square plus 22.986 squared divided by 2 into 11 into 22.986. The simple idea is that whenever the question requires an application of the cosine rule, it's going to give you those 4 marks there for applying the rule correctly and getting an answer out of it. So those are the marks here as well. And sorry, let's go down to Q. So cos inverse of this, I'm getting 119.7. Let's check. It looks like an obtuse angle to me. Yes, 119.7 is the right answer. Okay, then the third part of this question says the third row. That was the solution if you want to see it again. A third row is attached from P to a point T. TPQ equals to 40. PQT equals to 97. Find PT. So I think then this is a simple application of just the sine rule. I can find the third angle. I'm not talking about 3 dimensions right now. So 180 minus 40 minus 97. 43. So I can just say that sine 43 over 16.7 equals to sine 97 over x. So I'm going to have to do a bit of math algebra here. So sine 97 into 16.7 divided by sine 43. I hope that's the right answer. Yeah. Okay, this looks like a typical question about the cosine rule. I'm not really inclined to do this. This has a lower bound, so again, there would be something that I will have to do as a separate topic. So I'm going to skip that question. Let's look at this one because it has sort of a field that's in the shape of a quadrilateral. So ABCD is the floor plan of an exhibition which shown this. Calculate angle BCD. Now remember, whenever I'm trying to ask you these questions on quadrilateral, you cannot sort of directly use sine rule, cosine rule, or sine cos tan directly. You will have to cut it up into two triangles. So what I'm going to do is draw a straight line from B to D. Although that line might not have any significant interpretation in it would certainly have significance, but not any interpretations. That's absolutely fine. Okay, trying to be as accurate as possible. Okay, so it says calculate angle BCD, so I'm trying to calculate this angle X. Now I know that if I want to apply the, I don't have two angles inside this triangle, so I can't use the sine rule. But if I want to use the cosine rule, I must have this third side. Now I can see obviously that this third side is the hypotenuse of that other triangle. So I can say that hypotenuse squared equals to perpendicular squared plus base squared. I can reverse the order as well. So the hypotenuse comes out to be root of 160 squared plus 95 squared. 186.1. Let's call that 186.08 just to be more precise. Okay, then I can use that to apply the cosine rule that I have in the past applied as well. So I can say that cos x equals to, this side gets subtracted, 107 squared plus 165 squared. Okay, cos inverse of this entire thing. So cos inverse of 107 squared plus 165 squared minus 186.08 squared over 2 into 107 into 165. That gives me 83.4. I hope that's the correct answer. Yeah, 83.4. Then the last question, it says a light is attached to the ceiling vertically above B. So that's B and that's L. The angle of elevation of the light from C is 8.2. So whenever you have a question on angle of elevation or depression, make sure that you draw the diagram separately. So that's B and C. That length has to be 107. So that can tell me the height of this light basically. So that's what I can do. Then it says calculate the angle of elevation of the light from A. So A, L, it has to be at B. The light cannot move. It's going to have the same height. So I'm going to use again tan 8.2 equals to H over 107. So 107. 15.4. So that's 15.4. I'm standing at A now. What is that distance? It's 95. So that's 95. So theta, I've moved closer. That means the angle of elevation has gone up. Okay, so that comes out to be 9.2078. Correct to one decimal place because the answer is in degrees. That's what the requirement of the question is, 9.2 degrees. Okay, that brings us to the end of trigonometry for P2. There will be some more trigonometry when you do mensuration as well. So please make sure that you have your concepts figured out in terms of sine, cosine, sine, cos, tan. Angle of elevation and depression is something that comes up here. So just be aware of what this is. One thing that hasn't so far appeared is the shortest distance idea. That's generally a perpendicular line. It came up in one of the questions, but you can have more questions on that as well. So if you practice the older past papers, you will probably come across that. Please make sure to like and subscribe for more videos. Thank you.